Hello students, welcome back to our channel Diksha Karnataka. So as you know, mock test 6 is already released, and in my previous video I have discussed the part 1, that is question number 1 to question number 30. In this video I'll be discussing the second part, question number 31 to question number 60, and I hope you all have attempted the mock test. So please check the solutions and just let us see the first question now. So, okay, if you haven't downloaded the question paper is available in our WhatsApp channel. The link of the WhatsApp channel is there in the description section. Go there, download the question paper, attempt the mock test, and then come for seeing the solutions. First, coming to the first question. A galvanic cell is constructed using the redox reaction. This is given to you and it represents. So, this question is from cell notation, okay, electrochemistry, cell notation topic, very easy one. So what we have to do, first you have to identify which undergoes oxidation and which undergoes reduction. You can see here H2 is there and here H plus is there, right? So the oxidation state is changing from 0 to +1, that is hydrogen is undergoing oxidation. Now if you see Ag oxidation state is +1 here and then Ag is 0 here, right? So that means Ag is undergoing reduction. When you write the cell notation, the left part, okay, left part should be written for oxidation, then we have salt bridge, and then right part is written for reduction. You can remember right for reduction, okay, just a shortcut. Now we have, see, this hydrogen is getting oxidized to H plus, right? So that's why there will be no KCl here. So we can eliminate the first option. Now if you check here platinum by H2 is given. So this is actually, it should be written like this, PtH2HCl, okay, then so H2 is getting converted to H plus, okay. Then we have salt bridge. Here you can see AgCl is getting Ag plus, we can write from AgCl is getting converted to Ag. So this can be the correct answer. Let us see the other options here. Here H2 and this part is correct, okay, but AgNO3, this one is not there in the equation, so this part will be wrong. Now if you see this one, this is completely wrong because here oxidation is written on the right and reduction is written on the left. So this is also incorrect. So the correct answer for this question will be option number B. Very easy one, but you should only remember one. I'll tell you another trick here. Remember this one. Okay, L stands for left. On O we have oxidation. So always left side is oxidation. The other two is applicable for your galvanic cell, that is anode. Anode, A stands for anode, and anode is your negatively charged, okay. So just you have to remember these basic things. Now coming to next question, that is 32. Color of the light absorbed by aqueous USO4 is. This is very important concept, color of D block elements. Here we have to know something called as the complementary colors. So V, B, G, Y, O, R, right? This we know. Just in indigo color is not considered, it's because shade of blue. So we take these 6 colors to solve the questions. Now it is saying that the color of the copper sulfate, okay. So color of the light absorbed by the aqueous solution of copper sulfate. So first of all, what is the color of copper sulfate? We all know it is blue in color, right? It appears to be blue in color. So if the appearance is for blue color, then it must have absorbed the complementary color. So the complementary color is orange. Okay, so the correct answer for this question will be option A, orange and red, okay. So once again I'm telling, if the compound appears to be blue, it must have absorbed the radiation of its complementary color. So here the complementary color is orange and red, right? So the correct answer for this question is option A. Easy one. Next, degenerate orbitals for this one. So this is an octahedral complex. What is the splitting in octahedral complex? We have here 3 orbitals, T2G, that is your dxy, dyz and dzx, and here we have Eg orbitals, that is dz square and dx square minus y square. So which are your degenerate orbitals? Means they will have same energy. So first of all, what is the meaning of degenerate orbitals? Orbitals having same energy. So there are 2 sets of degenerate orbitals. First set is dxy, dyz and dzx. Second set is dx square minus y square and dz square. So you can see this xz and yz is there. Then we have dx square minus y square. This is wrong. X square and xz, this is also wrong. Yz and z square, this is also wrong. The correct answer for this question is option number A. Okay, next. The number of unidentate ligands in the complex ion is called. Definition based questions. In my video of coordination chemistry, I have told you some important definitions. So what is it? That is nothing but your coordination number. Okay, correct answer for this question will be option number D. Okay, next we have our organic reaction here. First, we have taken a cyclohexane with bromine, and when it is treated with Mg, this is the process to create the Grignard reagent. So what will be the product after treating it with Mg? We'll get MgBr. Okay. Now after this, it is taken with water. So if you have remember, this is the hydrolysis part. Plus we have here minus, and here we have H plus and OH minus. So this minus will take this H plus, and the product formed will be nothing but cyclohexane. Okay, so correct answer for this question will be option number D. Next, a reaction in which a primary amine is formed from primary amide is called. So if we have any primary amide, okay, from there if you are synthesizing RNH2, okay, so this C double bond O part is eliminated. So if you know, this reaction is called as Hofmann bromamide degradation, and it is, so whenever you see any conversion question, if the number of carbons has decreased, then you can guess it is a Hofmann bromamide degradation. So correct answer for this question will be option A. Name reactions are very, very important. So you must know the reactant, product and the reagents for every name reaction. Okay. Next. Okay, again one reaction based question based on reagents. Okay, NaBH4 is given and LiAlH4 is given, and the reactant is given. What is the difference between NaBH4 and LiAlH4? They both are reducing agents, but NaBH4 is a mild reducing agent, whereas LiAlH4 is a strong reducing agent. Okay, so it has the capacity to reduce the double bonds also, whereas NaBH4 can only reduce the carbonyl compounds. Okay, so now if why this compound is treated with NaBH4, this part will be reduced to alcohol CH2OH, and the alkene part will be undisturbed. So we can first figure it out, the Y part. Here this one is reduced, so this cannot be option. This can be there. Now we have this one is also cannot be answered because the double bond is reduced here. So we are now left with option A and option C. Now if we see with LiAlH4, in LiAlH4 this one, this carbonyl group is also reduced and the double bond should also be reduced. So if you check the option, this can be there, and this one here, this is completely wrong because we don't have the C6H5 group, right? So this part is eliminated. So the correct answer for this question will be option A. So I'll just write a note here. NaBH4 can reduce only carbonyl compounds, whereas LiAlH4 can reduce carbonyl compounds plus double bond. Okay, so just keep a note of this. Next question. Strongest acid among the following. These such type of questions are asked very common to find out the acidity order. So what should be the concept here? If we have electron withdrawing group, it increases the acidity. Electron donating group decreases the acidity. Now if you see here, we have Cl3 group, here we have one fluorine, here one acetic acid, and here we have 3 nitro groups. So confusion may be there with option C and D, because C is an carboxylic acid group, whereas D is an alcohol group with 3 nitro groups. So you have to remember this picric acid is a very, very strong acid, more than carboxylic acid also. So the correct answer for this question will be option number D. Okay, so please again a note here, picric acid is more acidic than benzoic acid. Okay. Next question. Which of the following will be colorless in aqueous solution? Again an application based question from coordination chemistry. How to identify colorless? The condition for colorless is it should not have no unpaired electrons. Okay, so we have to just check the electronic configuration of all the options, and then if they do not have any unpaired electrons, it will be colorless. What is the reason for this? It is because of if no unpaired electron, then no DD transition. Okay, so now let us see the option. Ti3 plus will have unpaired electrons, vanadium 3 plus will also have. So I'll just do for this one, scandium vanadium oxidations 3d to 4s2, vanadium 3 plus will be 3d1, so one unpaired electron is there. Copper plus is 3d10, 4s1. Copper plus means only 3d10, so no unpaired electron. This can be the answer. Now let us see Mn2 plus is 3d5, it has 5 unpaired electrons, it will be colored. CO2 plus is again 3d7, it will have unpaired electrons. If you see 3d7, 1, 2, 3, 4, 5, 6 and 7. So 3 unpaired electrons are here. Scandium is 3d1, 4s2. So scandium 3 plus is 3d0, 4s0. So no unpaired electrons here also. So the correct answer can be 3 and 6. So option number D. Okay. Okay. So you can solve these type of questions based on only if you have remembered the electronic configuration. So just remember from scandium to zinc, all the electronic configurations are very important to solve questions on color and to solve questions on magnetic properties. Next, magnetic moment of Cr2 plus is nearest to. So first of all, magnetic moment formula, if you know, that is equal to root over of n into n plus 2, where n is the number of unpaired electrons. Right? Now, if it is, so here they have not asked you directly the magnetic moment of Cr2 plus, it is similar to or it is equal to. So how many unpaired electrons are there in chromium? Chromium electronic configuration is 4s1, 3d5. Now Cr2 plus will have 3d4. So if you see 3d4 and you fill the d orbitals, we have 4 unpaired electrons. So out of these options, whichever will have 4 unpaired electrons will have a magnetic moment similar to Cr2 plus. So now if you check Fe2 plus, the electronic configuration is 3d6, 4s2. Fe2 plus will have 3d6. So now if we draw this 3d6 in this d orbitals, we have 1, 2, 3, 4, 5 and 6. So again we have 4 unpaired electrons. So 4 unpaired electrons, that is why this also 4 unpaired electrons. So magnetic moment value will be similar or nearest. So correct answer for this question will be option A. Next, lanthanide contraction is responsible for the fact that, so this is very important, there are some consequences of lanthanide contraction. One of the most important is zirconium and hafnium has the similar radius. So the correct answer for this question will be option number B. Okay, direct based question from consequences. Next, oxidation state of CO in this complex. So first of all, you should know the ligands charges, then only we can calculate the oxidation state. The metal whose oxidation state is to be calculated should be taken as X. So let the oxidation number of CO be X. Water is a neutral ligand, so its charge will be 0. Cn is a negative ligand with -1 charge. En is again a neutral ligand. 2 En are there, so it will again be 0. That is equal to total charge of the complex plus 2. So X is equal to plus 3, right? So charge of cobalt is plus 3. Correct answer for this will be option number B. Okay, next, amongst the following, the most stable complexes. So stability depends on various factors. One of the important factor is if you have chelating ligands or the ligands which form circular rings. Okay, so these type of ligands will enhance the stability. Now here H2O is a monodentate ligand, NH3 is also a monodentate ligand, but if you see C2O4, these are your bidentate ligand. Okay, if you draw the structure, we will get structure like this. Okay. Due to the ring formation, there is some extra stability. So the most stable complex will be your option number C. So here what you can note down, if we have bidentate ligands, they will increase the stability. Okay. Stability increases when we have more bidentate, tridentate or hexadentate ligands are present. The stability of the complex will increase. Next question. IUPAC name, one of the very important topic, coordination chemistry, all the rules you have to remember. So first of all, we will be naming the cation and then the anion. So here potassium is cation and the complex is anion. So first of all the options are having potassium here. So we cannot eliminate any option here. Now coming to this part, what is the oxidation state of nickel we can calculate. So for potassium 2, nickel is X, Cn is again 4, so 4 minus is equal to 0, so X is equal to plus 2, right? So you can see some of the options are having plus 3, we can eliminate those two options. Now we are left with option A and option C. Now if you know, if the complex, okay, is negative, okay, it's an anion part, then the metal name should end with ATE, okay, this one we should know, the metal name will end with ATE. Now nickel should end, since it is an anionic part, the complex is anion, nickel should end with nickelate. So if you check these two options, here it is only nickel, here it is nickelate. So the correct answer for this question will be option A. Nomenclature, many questions are asked. Please revise all the rules again and again and practice more questions on nomenclature. You have NCERT, many examples are given. So please practice nomenclature thoroughly. Okay, next question we have with reaction. Benzyl alcohol is given SOCl2, then treated with KCN. So let us do the first part. If you have CH2OH and you treat it with SOCl2, OH will be replaced with Cl group. So the product formed here will be CH2Cl, right? Now treating with KCN. So the role of KCN is to replace the Cl group with CN group. So we will get the next compound as CH2Cl. Okay. Now hydrolysis of this one, CN group on hydrolysis gives you acidic group. So we will get benzoic CH2COOH. Okay. So we can check the correct answer. Here you can get a little confusion between option B and D, but there is only one CH2 group. Okay. So correct answer for this question will be option number B. So very easy reaction based question from, I can say this first part is from haloalkanes, the last part is from carboxylic acid. Next, which of the following represents the correct order of boiling points? Very important question. Boiling point depends on two factors. So let us first revise this concept. First, it depends on the mass. Okay, as the mass increases, the boiling point will increase, and it is inversely proportional to branching. Okay, if the branching is there, boiling point will decrease. Now, if you see 1-chloropropane, 1-chlorobutane and chloropropane we have, right? So, first of all, butane is there. It will have 4 number of carbons, mass will be more. So, definitely butane should have the highest boiling point. So, you can say this option is also propane, this also is also propane. This is the correct one, 1-chlorobutane. Okay. Now, but we will check the other two part also. We have 1-chloropropane and 2-chloropropane. So 2-chloropropane is having branching here and 1-chloropropane is a linear chain. So that is why 1-chloropropane will have more boiling point than 2-chloropropane. So the correct answer for this question will be option number B. Okay, next. The reaction is given to you with, okay, this is again a name reaction. Fittig reaction we know. It is Woods reaction and Fittig reaction, and we have Woods-Fittig reaction. So this name of this reaction is Fittig reaction, option number B. Direct name reactions are asked, so please revise all the name reactions. Arrange the following compounds in the increasing order of solubility. Okay, so we have 4 type of compounds. This is one alcoholic functional group, this is normal hydrocarbon, this is aldehyde group, and here we have ether group, right, ethoxyethane. So if you remember, the alcohol groups have the tendency to form stronger hydrogen bonding, so they will be more soluble in water. So definitely first will be the one which is highly soluble. So we can eliminate option A. Okay, now compared to this one, next polar molecule is your aldehyde. So next soluble molecule will be aldehyde group. So after 1 we should get 3, right? So we can eliminate these all options here. 1, 3, 4 and 2. So hydrocarbons will be the least soluble because they are non-polar. So first we'll get N-butane, then we will have ethers, that is 4. Then we have aldehyde and then we have alcohol. So the correct answer for this question will be option number C. Next, which of the following reactions will not yield phenol? Okay, so here we have to know little reactions that what are the, so this question you can read from the methods of preparation of phenol. Okay, so there are 4 major reactions given for this, prepare all of them. So from this one, if you take, we will get Mg ether, MgBr will be attached to this one, and then when you treat with O2, this can give you phenol. Okay, this reaction is not there, but phenol can be produced using this reaction. NH2 we know, this N2 plus and Cl minus, and then you treat with water, we'll get again benzene. Here this Olea method is there in the preparation methods, very common method. Here this method of preparation is difficult. Okay, the reason for this one is chlorine is bonded to your sp2 carbon, okay, and here there is a partial double bond. So it is very difficult to break the bond between this carbon and this chlorine. So that is why this method of preparation is not correct. Okay, so correct answer for this question will be option number D. Okay, Other all can be possible, maybe at high temperature or low temperature, but this one will not be possible because this bond is difficult to break. Okay, next question. On boiling with concentrated HBr, ethyl phenyl ether will give. Okay, so this is your cleavage of ether. Under ethers, we have two important topics, that is Williamson ether synthesis, the methods of preparation, and we have cleavage of ether. Okay, cleavage of ether, many questions are asked. So there are some conditions for this one. First is ethyl phenyl ether. So what is the structure of this one? We have phenyl and then we have ethyl this side. So whenever there is a phenyl ring attached, the bond will break after O. Okay, that, and you have taken here H and I. Okay, so this O will be bonded to H and this one will be bonded to I. So we will get phenol and ethyl iode. So okay, it is with HBr. So this is Br. Okay, so we will get phenol with ethyl bromide. Okay, the correct answer for this question will be option number A. Next, which is the most suitable reagent for the following conversion? So we have, what is the conversion happening here? If you check, OH is getting converted to CHO, that is mild oxidation. So which K2Cr2O7, this will do more, it is a strong oxidizing agent. It can convert this to acid group. So the correct answer for this one will be your PCC, which is a mild oxidizing agent. Okay, so reagent based question, very important reaction. Next, arrange the following compounds in the increasing order of the ease of hydrogen bond formation. So hydrogen bond formation is depending, again as we have discussed, if we have alcohol functional group, they will form more hydrogen bond. First is your COH group, then alcohol group, then we have carbonyl compounds, and then we have ethers, okay, and then hydrocarbons. Okay, so if you see, this one is an aldehyde group. Next, this is one alcohol group. Here we have ether groups, and this is acidic group. So the most number of hydrogen bonds will be formed by the option 4, that is because of presence of acidic group. So fourth one should be highest, so we can eliminate option C and D, right? After this acid, it is alcoholic group, so both the options are having 2. Now after this, it is aldehyde, so after we have 1 and then 3. So the correct answer for this question will be option number B. So once again, see here, we have this acidic group which will be having more number of hydrogen bonds because of its structure. You can see this O is also involved in hydrogen bonding, this O is also involved in hydrogen bonding. So more number of hydrogen bonds will form. After 4, we have aldehyde group. So that is number 1. Then, alcoholic group. Then we have aldehyde group, and then we have ether group. So 3, 1, 2 and 4. Option number B. Okay, next question. We have to find the product Z. Okay, so first of all, when you treat this one with MgBr, it forms a Grignard reagent compound, that is NO2, and we will have here MgBr. Okay. Next, if you treat it with COOH, CO2, so this one will behave as a nucleophile attack here, and we will get benzoic acid. So we have NO2 group and we have COOH group. Okay, COOH group. So after adding this one, it will form. So this hydrolysis part is the addition of this water. So the correct answer for this question will be option number B. Okay, fine. Next question. In Clemmensen reduction, carbonyl compound is treated with. So it is a reagent based question. What is the use of Clemmensen reduction? It reduces any aldehydes or ketones to RC alkenes group, right? What is the reagent used here? Zinc amalgam, and in presence of HCl. The correct answer for this question is option number A. Okay. Next, what is the decreasing order of basicity of primary, secondary and tertiary amines and ammonia? So this is very important topic. You should remember for ethyl group. Okay, in aqueous medium, it is 2 degree, 3 degree, then 1 degree, and then ammonia. Okay, but if it is a methyl group, then we have 2 degree, 1 degree, and then 3 degree, then ammonia. Okay, the reason why this is different, it is because of your solvent effect, inductive effect. Okay, so the contribution of these two effects gives an experimental result. So the correct answer for ethyl group, it is asked here, Ethyl group is 2, 3, 1. So 2 degree, 3 degree, 1 degree, and then ammonia. Correct answer will be option number D. Next. What is Z in the following sequence of reaction? Again, we have one benzene. So we have aniline here. Okay, when you treat aniline with acylation, we will get NHCO and then CH3. So this is done to reduce the rate of reactivity of aniline. Aniline is a NH2 group present in benzene ring, is a highly activating group, right? So to reduce the reactivity, we do it acylation. Next, if you treat with bromine, Br2CCl4, so we will get here bromine in the para position. So the next product will be Y will be this one, and then when you treat it water, that is hydrolysis, this one will be converted to NH2 back. Right, so we will get para bromo aniline. Okay, correct answer for this question will be option number A. Next question. C3H9N represents primary, secondary, tertiary, all of this. So let us see. First of all, we can try with primary. Are we getting CH3, CH2, CH2, NH2? So if you check here, we have 3 carbons, 3, 4, 5, 6, 7, 8, 9, 9 hydrogen and 1 nitrogen. So we are able to do primary amine with this formula. Now let us try if any secondary amine is possible. So we can have this one, CH3, CH3 and then CH3, right? Sorry, we have this one. We can take this hydrogen here, NH, and one more carbon is there, so CH2, CH3 we can use, right? So here also this condition is fulfilled. We have 3, 4, 9 hydrogens and 3 carbons, 9 hydrogens and 1 ammonia. Next, if we try with this one, that is your tertiary one, that is also there. So all primary, secondary and tertiary structures can be done with the given formula. So correct answer for this question will be option number D. Next question. The rapid interconversion of alpha D to beta D is known as. So this is a definition based question, that is your mutarotation. Okay, the values you don't have to remember, but when the alpha form changes to beta form, we call it mutarotation. Okay. Next question. The pH value of the solution in which a particular amino acid does not migrate under the influence of electric field is called as. So what is the reason? First of all, amino acid, we have 3 structures on this one. So we have one carbon group. First we have to take the carbon group, and then it has one NH2 group, one COH group, one R group and one H group, right? So there is one particular pH value at which the structure exists in this form. Okay, this structure is called as Zwitter ion. So when the pH value where the compound exists in the form of Zwitter ion, it doesn't show any deviation towards any of the electrode, because it is a neutral compound, right? So that pH value is called as your isoelectric point. Correct answer will be option number D. Okay, so the last question in this one. Which of the following statement is not correct regarding the DNA? Okay, so it has a double-stranded beta helix structure. So we all know DNAs are alpha helix structures. Okay, right-handed, remember, right-handed alpha helix structures. So the incorrect statement will be option number A. Correct answer for this question is option A. It controls the synthesis of proteins. This is a correct statement. It has the unique property of replication. This is also correct. It chiefly occurs in the nucleus of the cell. This is also the correct statement. So the incorrect statement or the correct answer for this question will be option number A. So this was the last question. So I hope all of you have attempted the test. Okay, so I'll be happy if you can post your scores. Just check all the solutions. Post your scores in the comment section, and if you have any doubt in any question, so please comment down. I'll be addressing them in the next video. And if you have any other doubts, that also you can post. If you want, you can join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section. If you have found this video helpful, please like, share and subscribe the channel. Thank you.